Hey guys, let's take a look at dividing fractions. So you should be on page 47 in your hole punched Professor B workbook. That's the part in the back of your Fred workbook. And I know that with the test packet, I've already taught you the shortcut for dividing fractions, but today we're just going to learn why that works. And we have a little kitty visitor right here. So hopefully we'll move out of my way in just a second. All right, buddy, come on. I get that you like to do math. Come on, move. Okay. No, he just likes to be near me. So you'll get to see his little head for a while. All right. So I just want you to kind of have this understanding of why division works. All right. So let's start out with the following here. So let's start with 9 times 4 equals 36. And we've talked about this before, these fact families that you would have talked about. Remember, some of you had those triangle flashcards, and we have 9, 4, and 36 on there. And we could say that 9 times 4 equals 36, or 36 divided by 9 equals 4, or 36 divided by 4 equals 9. So this fact right here is related to this fact right here. All right, so 9 times 4 equals 36 means that 36 divided by 4 equals 9. And all we're doing here is we're just going in reverse. So here we went 9 times 4 is 36, and now we're going backwards. 36 divided by 9 equals 4. Okay, hopefully that's familiar. All right, using the same logic above, we can say that 8 times 12 is 96 means that, and again, we're going to go in the reverse order here and write it as division, that 96 divided by 12 equals 8. All right, so again, we're taking that same fact family, 8, 12, and 96. These two multiplied together give us 96. 96 divided by 8 is 12, and 96 divided by 12 is 8. Okay, so now let's look at one that's a little bit more complex, just because we've got 3 things multiplied here. So now let's consider 2 times 3 times 7 equals 42. Again, we know that 6 times 7 is 42, and right here, this 3 times 2 is 6 times 7 is 42. So if we had to write a fact family card, oh my goodness, he's so annoying. We would put the 7 down here. Move out of the way. We would put the 7 down here, and we'd put the 2 times 3 right here. All right, so we know that 2 times 3 times 7 is 42, but now we're asking if we had to write this as division, 42 divided by 7, what would that be? All right, hopefully you would say 2 times 3. All right, let's look at this one. 5 times 4 times 3 is 60. Again, 5 times 4 is 20, so 20 times 3 would give me 60. So I can say, again, if we set up a little card here, this would be 5 times 4, and this would be 3. So 5 times 4 times 3 would be 60, or we could do 60 divided by 5 times 4, and that would give us 3, or 60 divided by 3, and hopefully you'll say it's 5 times 4. Okay, now you do this one. Since 7 times 2 times 5 is 70, we can say that 70 divided by 5 is... Hopefully you said 7 times 2. All right, again, we're going backwards from 70. So 70 divided by 5 has to be whatever's left over here. Okay, and then one more here. 6 times 2 times 3 is 36. Again, 6 times 2 is 12 times 3 would be 36. So then if we go backwards, 36 divided by 3, hopefully you said should be 6 times 2. Okay. So let's take a look. Now, again, this is all about dividing fractions. So far, all we've been doing is taking multiplication problems and rewriting them as division. But I want you to see it's because these are, we're going to start looking at fractions and we're going to see that they are the same. Okay, so let's take a look at this. 2 times 7, or 2 sevenths times 3 fifths times 5 thirds equals 2 sevenths times 1, which equals 2 sevenths. So let's go, and I've got the question, why the heck is that true? So let's look at this. 2 sevenths times 3 fifths times 5/3 equals 2/7 times 1. Now let's look at what's stayed the same and what's changed. So in both of these, we have a 2/7 first. In the first problem here, we have 3/5 times 5/3, and in the second problem, that is no longer there, and in place of that, we have a 1. All right, so let's look at this. 3/5 times 5/3. Well, what is that we would change that or get rid of it and replace it with a 1? So hopefully you can see either by doing our original method of multiplying straight across, 5 times 3 is 15, and then in the bottom, 5 times 3 is 15. We get 15 over 15, which is 1. Or you could cancel first and notice that 5 and 5 share a common factor. So 5 goes into 5 once, 5 goes into 5 once. Same thing here, 3 goes into 3 once, 3 goes into 3 once. Oops, 1. And then we would just get 1. So the 2/7 did not change at all, but we grouped these, the 3/5 times 5/3 together, multiplied them, and got 1. Okay, and then 2/7 times 1, hopefully it's not a shock that we would then say that that's 2/7, because anything times 1 is itself, right? So we get 2/7. Okay, so do you believe then that we can say that 2/7 times 3/5 times 5/3 equals 2/7? Right, I'm just skipping this step right in here, and I'm saying that this side equals this side right here. Okay, hopefully you're good with that. Again, if not, go back and watch that part again. All right, so now we have this, and again, it's just like everything we've been doing in these previous steps. We've got 3 things multiplied together equals a single number. And again, before we started out with nice, easy whole numbers equal to whole number. So the only difference between what we did before and what we're doing now is that now it's all fractions. All right, so we've got 2/7 times 3/5 times 5/3 equals 2/7. Now, if we're going to rewrite it like we did here, we're going to take this and we're going to start with the 2/7 and we're going to work backwards. And we're going to say 2/7 divided by 5/3 has to equal whatever's left over here. 2/7 times 3/5. Right? And again, if we set up a fact family, this would be such a weird card, but it would look like this. 2/7 would be at the top because that's the answer. And then 5/3 would be in one corner, and then the other thing would be in the other corner. 2/7 times 3/5. Sorry, I'm writing that slanted because I'm kind of squished. Okay, so 2/3 times 3/5 times 5/3 should give us the 2/7, or if we start and go backwards, 2/7 divided by 5/3 will give us this. All right, so based on our work above, we can say that 2/7 divided by 5/3 equals 2/7 times 3/5. All right, and again, it's all based on this, that we're just taking this, multiplying 3 numbers equaling a fraction, and we're writing it as a division fact. All right, and so we get 2/3 divided by, 2/7 divided by 5/3 is 2/7 times 3/5. Okay, now let's look at this. So here is one that's very similar to this. It has that same pattern. We've got some fractional value up here. We've got a pair of fractions here. Now let's go back and look at this. I've scribbled it out, so let me just erase it and start over. Look at the relationship between these two fractions. Notice how the 3 in the numerator here and the 5 in the denominator flip-flop in the second fraction. So 3/5 becomes 5/3. We say that we flipped the fraction, and we can also, in a fancy way, we would say that 5/3 is the reciprocal. That's a hard word here. I'm going to write it down. Reciprocal. Right? That's when we take a fraction and we flip it over. All right? So the reciprocal of 3/5 is 5/3. All right, that's how we would use it in a sense. But if you prefer, you can just use the word flip. That's what a lot of people do. All right, so notice we've got that same pattern set up here. 2/5 and 5/2. We have the flip of 2/5 right here, or the reciprocal of 2/5. So what did we notice about it in this previous problem? What did it equal when we multiplied the two of them? Hopefully you said 1. So then we have 3/8 times 1. That's what this equals, which just is 3/8. So if we were to write that as division, we would say 3/8 divided by, we're going to work backwards now, we're going to take the 5/2, and it equals whatever is left over, which is 3/8 times 2/5. Okay, let's take a look at this one. 4/9 times 8/3 times 3/8. Again, we've got here a pair of reciprocals. The reciprocal of 8/3 is 3/8. So we know that when we multiply these together, we get 1. So 4/9 times 1 is just 4/9. Now it's asking us to rewrite this as division. So we're going to start with our answer, 4/9 divided by the first thing we come across, which is the 3/8. And that equals 4/9 times 8/3, whatever we didn't use. So we didn't use this part. All right, let's do one more, and then we're going to talk about what the pattern here is. What is this saying to us? All right, so we've got 15/3 times 7/9 times 9/7. Again, 9/7 is the reciprocal of 7/9. So when we multiply these two together, we get 1. So 5/13 times 1 is 5/13. All right, now we're going to write it as division. So we start with the last number, 5/13 divided by whatever comes right before the equal sign, which is 9/7, and it has to equal this part right here, 5/13 times 7/9. All right, so in other words, to summarize, I'm just going to take and write all these things right here. 3/8 divided by 5/2 is the same thing as 3/8 times 2/5. All right, that's just came from right up here. 4/9 divided by 3/8 is the same thing as 4/9 times 8/3. That came from this one. 5/13 divided by 9/7 is the same thing as 5/13 times 7/9. All right, so what do you notice about each of these? Look for patterns here for me. So think about that for a second. If you want, just stop and pause the video while you look at that. Okay, so hopefully you're noticing that in each case, the first number on this side is the same as the first number on this side. 3/8, 3/8, 4/9, 4/9, 5/13, 5/13. Hopefully you also noticed in every single problem we had division on this side, and then we have multiplication. Division, multiplication, division, multiplication. And in every one of these cases, the second number, the number that came after the division sign, the number that we're dividing by, on the right side of the equation, that it's reciprocal or it's flip. So 3/8 divided by 5/2 is the same thing, and will give you the same answer as if you do 3/8 times the reciprocal of 5/2. Same thing here. 4/9 divided by 3/8 is the same thing as 4/9 times the reciprocal of 3/8. 5/13 divided by 9/7 is the same thing as 5/13 times the reciprocal of 9/7. So what we're going to do, since we already know how to multiply fractions, and we found them pretty easy so far, that what we're going to do is anytime we see a division of fractions, what we're going to do is we're going to rewrite it as multiplication, because that's easy for us to do. So how can you easily transform a division problem into an equivalent multiplication problem, which is what we've been doing. We've been taking a division problem and changing it into a multiplication problem. All right, again, that started right at the beginning. We're taking a division problem, or actually we were doing the reverse. We were taking a multiplication problem and turning it into a division problem. Now we can say we could easily go the reverse direction. Anytime we're given a division problem, we can easily rewrite it as a multiplication problem. And how would we do it? Well, I would say keep the first fraction the same. All right, every one of these has the exact same fraction first. Change the sign or the operation from divide to multiply. All right, every single time here it was divide, then every single time on the new expression it was multiply, and then flip the second fraction. All right, you should recognize that from memory work, keep, change, flip. All right, for short, we write keep, change, flip. This means keep the first fraction the same, change the sign from divide to multiply, flip the second fraction. All right, and it all is related to fraction families. All right, and we've just written, you know, a nice expression here that helps lend to getting that, the new fraction expression. Instead of division, we're going to write multiplication. Okay, let's look at page 47. No, we are on page 47. Let's look on page 48. So the steps to doing a division problem, again, this is just summarized up here. To transform the division problem into a, first thing you're going to do is transform the division problem into an equivalent multiplication problem. And again, we're going to do that. Keep, change, flip. Keep, change, flip. Do the multiplication problem by reducing first if possible, then multiplying across. And then if the answer to the multiplication problem is an improper fraction, change it into a mixed number. And then the answer to the multiplication problem is the same answer as the answer to the division problem. Right? So this is the most important part. You don't have to do anything else. Once you change this into a multiplication problem and do it out, that is the answer to this problem. All right, so let's try one here together. So here's an example. So it's saying 15/16 divided by 25/14. So again, I notice, oh, I have a division problem. I'm going to use keep, change, flip, right? Because the answer to the multiplication problem I will get when I do keep, change, flip is the same as the answer I will get for this. All right, so I'm going to keep the first fraction the same. That's 15/16. I'm going to change the sign from divide to multiply, and I'm going to flip the second fraction. So 25/14 becomes 14/25. Okay, everybody good? Okay, so that is the first step that we did. Transform it into a multiplication problem using keep, change, flip. All right, then do the multiplication problem by reducing first if possible. So let's look if we can reduce first. So let's look along the diagonals. Do 16 and 14 share any common factors? Yes, they do. They both have a 2. So 16 divided by 2 is 8. 14 divided by 2 is 7. Do 15 and 25 share any common factors? Yes, they both share 5. So 15 divided by 5 is 3. 25 divided by 5 is 5. Look up and down and make sure there are no common factors there. No, 7 and 5 are both prime. 3 and 8 don't share a common factor. 3 is prime, so the only factor that it could have in common with 8 is if 8 had a 3 in it, but it doesn't. So now we're just going to multiply across, right, because that's the next step. Multiply across, so we'll get 21/40. If the answer is an improper fraction, which it's not, so we don't have to do that, then the answer that we get right here is the answer to this. So the answer to 15/16 divided by 25/14 is 21/40. All right. Okay, we're going to skip these right here because these all deal with dividing mixed numbers, and we have not talked about that. So don't lose this page. We're going to come back and look at it later. But let's then go on to page 49.